Do you know just by lighting up the LED lamp you can get high-speed internet? Yes, it is true that high-speed internet can be achieved using LED lamps with LiFi technology. LiFi uses visible light communication, VLC technology to transmit data between devices using light waves, a technology so mysterious and revolutionary, it has the potential to change the way we connect to the world around us. For years, we've relied on Wi-Fi to keep us connected. But what if we told you that there was a new technology on the horizon? A technology that uses light to transmit data, allowing for faster, more secure, and more reliable communication. This is LiFi. Using the power of light, LiFi has the ability to unlock new levels of connectivity. Talking about discovery, Harold Haas is a professor of mobile communications at the University of Edinburgh, and he is known for inventing LiFi technology. On July 12, 2011, Haas gave a TED Global talk in which he demonstrated the potential of LiFi. As the lamp transmitted the video, the photodetector captured the light signals and converted them into electrical signals, which were then processed by the computer and projected onto a screen behind him. How it works. But how does it work? How can light be used to transmit data? LiFi works by using a special type of light that can be turned on and off rapidly. By modulating the light in this way, we can transmit data at incredible speeds. Operational procedure is very simple. If the LED is on, it transmits 1. If it's off, then it transmits a 0. The LED can be switched on and off very quickly that the human eye cannot even detect it. A special controller that codes data into those LEDs is required. The data flow rate varies upon the flicker of the LEDs. Every light source will work as a hub for data transmission. They're a transmitter or receiver. That means an access point mounted into the ceiling and USB dongle should be connected to the device. Where we are going to access the internet. Pure LiFi, the company which designed the module, says the module will be compliant with the upcoming IEEE 802.11bb Light Communication Standard, which is in its final stages of ratification. LiFi provides not only inherent military-grade security but also facilitates fast, dependable, and congestion-free communication. Compliance with the upcoming IEEE 802.11bb standard means LiFi can easily integrate with existing Wi-Fi chipsets in billions of devices. LiFi and Wi-Fi are two different wireless communication technologies that have some similarities but also some key differences. If we compare LiFi versus Wi-Fi, LiFi is not just faster than Wi-Fi. It's also more secure. Because the light used in LiFi can't pass through walls, it's much harder for hackers to intercept or interfere with the signal. This means that LiFi signals cannot be intercepted by hackers or other malicious actors from outside the room. Wi-Fi signals, on the other hand, can be intercepted and potentially compromised. Speed of LiFi is capable of much higher data transfer speeds than Wi-Fi, with theoretical speeds up to 224 gigabits per second, whereas Wi-Fi speeds top out at around 10 gigabits per second. This is because LiFi uses visible light communication, VLC technology, which has a higher frequency and wider bandwidth than radio frequency, RF, waves used by Wi-Fi. If we talk about range, LiFi has a limited range because it requires a direct line of sight between the transmitter and the receiver. This means that LiFi signals cannot be transmitted through walls or around corners. Wi-Fi, on the other hand, has a much longer range and can transmit signals through walls and other obstacles. Let us say, how about interference? LiFi is not affected by electromagnetic interference from other electronic devices, which can cause problems for Wi-Fi. However, LiFi can be disrupted by ambient light sources, such as sunlight, which can interfere with the signal. At last, will LiFi take over Wi-Fi or not? Wi-Fi technology is already widely deployed and requires minimal infrastructure to set up. LiFi, on the other hand, requires specialized equipment, such as LED lights and photodetectors, to transmit and receive signals. This makes it more expensive and less practical to implement on a large scale. LiFi can be used in airplane. LiFi technology may offer some advantages over Wi-Fi in an airplane environment. One advantage of LiFi is that it uses light waves to transmit data, which cannot penetrate through walls or physical barriers. In an airplane, this could be beneficial because it could reduce the risk of interference with the aircraft's avionics systems, which is a concern with traditional Wi-Fi that uses radio frequency, RF, waves to transmit data. Additionally, LiFi technology can offer higher data rates compared to traditional Wi-Fi, which could improve the in-flight entertainment experience for passengers. Furthermore, since light waves do not interfere with other electronic devices, LiFi may be a more secure and reliable solution for transmitting sensitive information. By using solar panels as receivers for LiFi, it is possible to create a sustainable and energy-efficient system for data transmission. The solar panels can capture and convert the light energy from the LiFi signals into electricity, which can then be used to power the electronic devices that are receiving the data. This can potentially reduce the overall energy consumption of the system and make it more environmentally friendly. Yes, LiFi can be used in conjunction with solar panels to act as a receiver for data transmission. In fact, using solar panels as receivers for LiFi has been proposed as a way to increase the efficiency of both technologies. And solar panels are designed to capture and convert light into electricity. The solar panel would essentially act as a photodetector. There are 6.92 billion smartphone users in the world according to Statista in year 2023. It means 86.29% of the world's population owns a smartphone. This figure is up considerably from 2016, when only 3.668 billion users were 49.40% of that year's global population. And 7.93 billion people have mobile phones in the world. It indicates 91.40% of people own mobile phones today in 2023, including both smart and feature phones. The number of smartphone mobile network subscriptions worldwide reached almost 6.6 billion in 2022, and is forecast to exceed 7.8 billion by 2028. China, India, and the United States are the countries with the highest number of smartphone mobile network subscriptions. 1.48 billion mobile connections worldwide, which surpasses the current world population of 8.019 billion implied by UN digital analyst estimates. That means there are 3.129 billion more mobile connections than people worldwide. Have you ever thought of how does a cell tower works? When a mobile device such as a smartphone or tablet communicates with a cell tower, the device sends and receives radio frequency signals over the airwaves. The cell tower then relays the signal to the cellular network, which in turn relays the signal to the receiving device. Transceivers are the electronic components that convert the radio frequency signals into digital data. That can be transmitted over the cellular network. And power supply. The cell tower requires a constant supply of power to operate, which is typically provided by a local power grid or backup generator. When a mobile device, such as a smartphone or tablet, moves from one place to another while communicating with a cell tower, the device automatically connects to the nearest cell tower. This is because the cellular network is designed to constantly monitor the signal strength and quality of the connection, and to switch the device to the nearest available cell tower when necessary. As the mobile device moves away from the current cell tower, the signal strength and quality may start to deteriorate. The device then begins to search for nearby cell towers that have a stronger signal, and when it finds one, it switches to that tower. The process of switching between cell towers is known as handover, and it is an essential part of the cellular network. The handover process is designed to be seamless, so that users can move around and continue to use their devices without interruption. When a mobile device switches to a new cell tower, it sends a signal to the new tower to establish a connection. The new tower then sends a signal to the old tower, informing it to release the connection. Once the old tower releases the connection, the new tower takes over the communication with the mobile device. Overall, the cellular network is designed to provide seamless connectivity to mobile devices as they move from one location to another. This is achieved through a complex system of cell towers and handover processes that work together to ensure that users can stay connected no matter where they go. The world is constantly changing and evolving, and as technology advances, so does our need for reliable communication. That's why there's now an estimated 1.5 million cell towers spread out across the globe. You may not know it, but your phone is constantly communicating with these towers, sending and receiving signals that allow you to make calls, send texts, and browse the internet. Overall, LiFi and Wi-Fi have different strengths and weaknesses, and each technology may be more appropriate for different applications depending on the specific requirements. While LiFi has some advantages over Wi-Fi in terms of speed and security, it is still a relatively new and experimental technology that has yet to be widely adopted. Stay ahead of the tech curve and join our exclusive community of subscribers to receive top-quality content that will elevate your knowledge and keep you on the cutting edge of innovation. Thanks for watching. Don't forget to subscribe, like, share, and comment down.